or not invites, names afterwards. I want to get things moving. If you want to do introductions. Yeah. This is your machine, or? Oh, sure. Yeah.
All right, cool. Thanks for having us here today to give a talk about intro to testing. As introduced, my name is Steven, and this is Uzair. I'm an iOS developer with Connected Labs. I've been there for coming up like a few months, short of a year. I've had about 4 years of experience in iOS development, so I'm still pretty new to all this.
Yeah, so my name is Uzair. I'm an engineering manager at Connected Lab, and so I've been at Connected Lab for almost under a year as well. Prior to Connected Lab, I was iOS developer for almost 6 years, so a lot of background in iOS development. We'll test today.
Cool. So what we're hoping for you guys to get out of this talk is 3 things. Maybe like a better heuristic mindset to testing. Some idea of like where and how to get started if you haven't done it before, and remove a few mental hurdles about hey, I don't want to test because of whatever reasons. Here's a brief overview of what we're covering today. We're going to talk a little bit about why testing. We'll talk a little bit about some principles surrounding testing and kind of sometimes testing can be bad, poorly written tests, and how does that affect the code base. We're going to talk about a very specific way of doing test-driven development called behavior-driven development. Talk a little bit about where to start, the tools for doing that, and then just a few objections, common things that come up about testing that hopefully we can kind of talk about. So, why testing? So just like a show of hands, how many of us here has done unit testing? Okay, so everybody. Who would consider themselves experienced in unit testing? Okay, cool. Who has their unit test hooked up to some sort of continuous integration? Okay, that's a good amount. So we're a pretty experienced crowd. So maybe some of this stuff will be review for you guys, but hopefully you'll still get something useful out of this. So why testing? I'm going to quickly mention 3 reasons. So the first one is living documentation, right? So living documentation, what does that mean? A coworker of mine, I like the way he describes it. Documentation is like a parallel code path to your code, and it falls out of sync really easily. How many of us have looked at documentation and then actually used it, and it totally does not do what it says it does, right? So tests are kind of like living documentation in the way that they catch divergence from documented behavior, and they basically enforce it so that you have to correct that behavior, or you have to fix up the documentation, right? And so it reduces regression and I'm just gonna fix this up and confusion, and it provides an interactive way for people to learn about your code base. So maybe someone wants to know what this particular method does. They could actually just comment it out or change something about it, see what breaks, and then read what the tests are doing. So kind of learn a little bit about what the code base is doing. So second reason, design critique. So for the design critique, it's actually in 2 ways. One is from an engineering perspective. That is architecturally, it helps you think a little bit more better about architecture, but also from an app design perspective. So well-architected code tend to also be pretty testable, and well-architected apps also tend to be, well-designed apps tend to be also very testable. So just an example, usually testing will force you to think about things like value types versus reference types, passing pointers as opposed to so things like this Usually passing like pointers or like references will result sometimes in test contamination. So it forces you to think about, hey, is this the only way I could do this? Another example is it forces you to think about things like dependency injection. So, for example, maybe there was a class and you were initting and there's like some hidden global dependencies on UI application to link to somewhere else, versus if you had it initted with like a protocol that was like doing kind of that sort of routing stuff. So it's very clear about very explicit specifications as opposed to like obfuscating some of those details and hiding them in the class and making them hard to test, right? So next, how does that, like, sometimes you get a request like design where like you have a registration flow and this button right here, instead of popping to the previous part of the form, like pops all the way out of the registration flow, right? And it's actually kind of like, it's kind of unintuitive for the user. The user doesn't, like when they hit back, they're thinking they're going to the previous page, but they're like popped all the way out. Right now, writing a test and writing classes that do that is actually much more difficult because you have to have a higher level manager of some sort to do the routing. And because it's hard to write the test, it actually kind of catches a little bit of a design smell, right? So, so testing also helps you just build better apps, follow like maybe platform conventions and stuff like that.
That's the question.
Sure.
Why does testing do that versus just doing that?
Good question. So,
and then to your previous comment about dependency injection,
yeah.
Why isn't just thinking about dependency injection make you know this dependency, you should use dependency injection rather than your test case force you?
Right. Right. So there's no reason you can't actually do that. I would say like testing forces you to think about it. So you're less like, I guess it exposes bad habits a little bit. So like not doing places where you may have hidden dependencies that you haven't really thought about when you're trying to test it will reveal that to you. If that makes sense.
Sure.
Cool. All right. So the third reason is basically, I'm pretty sure like most of us have heard this, moving quickly and safely over time. So it's like once the code base grows, it's really hard to feel safe making changes and like, oh, what else is this? Like what other problems this might be creating if I'm changing it, especially code bases where you have like view controllers that are like very, very large. Large code you have to have like a large amount of tests to go with it. So testing will also kind of force you to go think smaller classes, modularized things, and they kind of put a safety net around your code so that you can make quickly and safely over time. But, right, when writing tests, like, how many of us have seen tests like this? Like test fetch user, or test did select row for index path, or a lot of setup for a lot of test setup, and then just like some sort of data handler, fetch user, and then right after we check like data handler is fetching user, right? So like these tests, like this one almost seems like a tautology. It's like, what am I actually testing, right? And these ones right here, like, what do those tests tell me about what the code is doing? Like, it's literally just doing some sort of like table view, like selection, whatever. So what this is trying to bring out is the fact that like we need some principles to testing. So it's useful so testing is more, I guess testing is more than just having automated checking of things. It's about like when we think about living documentation, think about like all the things that we talked about to achieve that. It's quite a bit more than just writing things that automate. So what are some principles of testing? First, I would say convey behavioral value instead of verifying implementation. So this means like properly naming your tests, describing the behavior. Don't just like basically like write another version of the code implementation in your test name, right? Like that's not effective. Too. So let's look at an example. So that example we saw did select row for next path, or sometimes like you see a test that just says like manager A should hit manager B, or like this should happen, right? They're very uninformative, because it doesn't actually describe what the code is trying to achieve. It just talks about what the code is doing. Right? It doesn't convey any additional information to someone who comes by who's looking at this test, who's trying to figure out what they have to watch out for if they're refactoring. Like, what are they trying to achieve? Right. So some better test names would be that. So for example, this select row, that should have been maybe function test drill into list item details. Like, that's more descriptive. It's saying I'm trying to get into a detailed view or something. And then that second one, instead of manager A hitting manager B, be descriptive about what manager A is and why it needs manager B to do what it's doing. So in this case, maybe fetching user data should ask for some sort of auth token from the keychain service or something to use in its request. Right? That's a lot more descriptive. The person who comes afterwards, if the test fails, knows what it's trying to achieve. And if they're changing the code in a big way, they feel safer doing that. So next is think input output, not step 1, step 2. So what that means is a lot of times when we test, we actually purposely expose method names, we expose properties so that we can get to that point in the test where there's a particular test class we're testing, and there's different method calls on it, and we are basically verifying the various steps that it's hitting. So maybe, I'm trying to think of an example. I guess, like maybe some sort of data parsing thing, right? First you get like NS data back, and then you like convert it to something else, and then you check that that class now has it in something else, and convert it to like some sort of string, or finally a data type that you have, and you check them at every step. Think input output, not so much like, oh, I know what it's going to do, so I want to make sure it's doing that at every step. Think from the outside in, always from like the user's perspective. So like usually a good way of doing this is like just looking at the header file or what's public. And if like basically if the user doesn't know about it, you probably shouldn't be touching it, right? So basically have a mindset of formalized black boxing. So let's look at an example. This is a very simple test. It says this is probably some sort of view controller, and it has a label, and it's testing that the label should have received a selector call set text, and the parameter supply should be high, right? So maybe a better test would be subject.label, and then just checking that the text is equal to high, right? See, this one tests a step in the code, and the second one tests like an output. So thinking input output as opposed to step 1, step 2, right? Cool. So next, be precise and concise. This is kind of like clean code practices, but applied to tests. What it means is that write tests that are short, that could be easily run in isolation. So if a test fails, you can easily just like zoom in on that test and see like why it's failing, put breakpoints without having to like walk through many times. It also helps you be able to run it automatically in some sort of CI/CD environment. Also, don't assert multiple outcomes in a particular test. Try to assert individual outcomes so that so you can know which part of what you're looking for is failing. So an example is function test show available data, and then in here maybe you're asserting on the header to show that like the header is showing the correct thing, and then you're asserting that there's the right number of cells and the cells are showing the right things. Maybe there's a spinner, and maybe there's a request that goes out, and you're testing all those things in a single test, right? Maybe a better way of doing that would be to write a set of tests that describe any sort of initial loading actions, and then from there having individual tests that check for those individual like behavior that you're looking for. It makes it like a lot easier to read, a lot easier to understand. So all of this adds up to just like what I think is the main principle, which is focus on the person after you. What does that mean? It means that like paying like attention to detail. So that test that we saw where we were checking the text being equal to high, maybe you should use a different like matcher saying like subject label.text should equal this. So when this test fails, it's going to say expected false, sorry, expected true, but got false. That doesn't tell the person who's looking at the failing test anything, right? This one, if the text was being set incorrectly, for example, maybe capitalization was wrong, it would say expected lowercase high, but got like capital case high, right? So like the person immediately knows like where the test failed, how it failed, and what needs to be fixed. So pay attention to the small details. They really matter. Like 100 small details add up to like really good tests. Like tests, the test suite often is treated as kind of like a second-class citizen. Treat your test suite as first-class citizen. Maintain it. Try to make it as readable, as understandable, as feedback-oriented. So it should give good feedback. When it fails, it shouldn't be like I can't figure out why it failed. It should be very like easy to read, expressive. Like you shouldn't have like huge amount of setup, a huge amount of like nesting and things like that make it really hard to understand what the code is doing. Try to abstract some of that out, and it should be like maintainable and robust to change, which means that like as we saw, try to be as implementation agnostic as possible. Don't test like a step in the middle. Try to be like input output oriented. Cool. So, nice. So how do we achieve all this? So I'm going to talk a little bit about behavior-driven development, which is something that we're trying to like get into a bit at Connected. It's basically a special way of doing test-driven development with a special focus on like what the acceptance criteria is. It's like a formulated or disciplined way of approaching testing. So testing begins with well-defined stories. So writing good tests is not just a developer initiative. It actually starts with, I guess, the PM, and then maybe before that, the designers. So it's like a whole team initiative. Breaking down any given feature into bite-sized, like well-modularized pieces of logic is really important for writing good tests. See an example. So this is an example of a story that you might see. It says like add a fetch data call to the user service with the auth token in the header. So this sort of test tends to get you when we see this sort of story, we tend to write the tests that are very functional or structural oriented. We'll say like user service should like hit something else with an auth token, like because it doesn't describe the value of why we're testing that, right? So a better way of writing that story might be actually describing why we want to do that and what it's trying to achieve. So it could be like Jimmy wants to know his latest bank balance. He lands on the user profile page, and then a secure request for his updated balance is made. So by doing that, when we're writing the test, we can actually write why we're doing it and like what it's trying to achieve, as opposed to just like structurally what the code is doing. Cool. So how does that look different from XC test? So there's a bunch of, I guess for Swift there's really only one, but there's frameworks that you can use to do behavior-driven development. The frameworks enable you to do things like focus testing. So if you put a focus F in front of this, it'll only run a particular set of tests. It allows you to do exclusions. Some of them will do randomization for you, so run tests in different orders to like check for contamination. So maybe like if you run a test first and you run another test second, it'll fail or pass. So it'll try to spot like where your test is not great. And it also forces you into this given when then kind of thinking, input output. So for example, in this test right here, it's saying it's basically saying test fetching last balance, and then the dependencies are stated very clearly. This is a test subject. This is some sort of mock authentication service, and then we mock it up. We create that subject, and then we say we want to fetch the balance, right, based off the previous story. and then we say it should make a secure balance request with the user's token, and then we assert on something there, right? So maybe our mock auth service should have received something. We should have like done something there. So,
What is the get part?
Yeah, I was going to say the same thing. It seems like you've left out the most salient part of that test.
right.
I know I don't want to like sound like there's a, but the setup is like, what happens inside of it.
So this is some sort of assertion. Yeah, I didn't put it there. I guess it would be like mock service dot like has received request for auth token or something should be true because it is a dependency of our subject.
That,
So the assert is in there?
So we were insert the assertion.
so we're asserting that the mock auth service got asked for a token.
Yeah.
Even though most of this talks about fetching the latest balance.
Yep. So this right here should probably say, like maybe there's another dependency somewhere that's like make a network call or something like there's like a network manager. There's a second dependency. So there may be several its here. That's like checking.
It's inside of this described.
Yeah. So you want to have, like I mentioned, you don't want to assert on multiple things within a test. So this one just checks that it's using the auth token. Maybe the next one would check that it's making the network request.
So each it would be a test inside of this describe, which is a suite of tests.
In one of your previous slides, you mentioned that you should consider it as an input-output, so you're considering it as a black box test, but you are very much white box testing the implementation details of what's going on here. How do you justify that? Those two.
So yeah, you could go like really, really modular. So I guess it depends on how you see a unit of code. So in this case, I would view this authentication service as a dependency. And the moment I've declared it as a dependency, meaning that it's one of the inputs, it's visible to the outside world. That you can't create a user service without supplying it some sort of auth service. So you know that the user service needs it. Right, so what we're doing here is we're actually manipulating the input and setting the preconditions for this test. And then when we trigger the test, that's when we say we're fetching the balance info. We're expecting the subject to use that in some way. But we don't know how it's using it. We just expect it to use it in some way.
Can you name some of those frameworks?
Yep. So how do we do this? Where to start? So for Objective-C, Kiwi, Specta, and Cedar are kind of the three big ones that I've seen used. Kiwi is probably the most popular. To do dependency injection, Typhoon and Blindside are pretty good. Like the last two are a little bit less well known, but Typhoon is a really well known one. And for Swift, there's really only just one set that you could go with, which is Quick and Nimble. Quick gives you the RSpec BDD style type of tests, and then Nimble gives you a whole bunch of different matchers that you can use, and it allows you to even write custom matchers. So maybe you're trying to test CL location. Maybe there's some structs that there are no natural equal comparisons. You could write custom matchers and stuff. And then dependency injection would be Swinject. I think that's the most popular one. It's important to know that you don't need a dependency injection framework to do dependency injection. I did put these up because I find that for a lot of testing, it forces you to think input-output. You try to pull dependencies out of your code, and you do end up wanting to do dependency injection. So it's very helpful to have a framework, but you don't need one. It's very easy to kind of set it up yourself. Yeah.
If your system is architected around the idea of dependency injection.
So dependency injection framework abstracts state. So for example, if I go back to this right here, maybe this mock auth service is actually a singleton within your app. So it's the same instance for the lifetime of your app. But according to this test, your user service has no idea that it's a singleton. right? So the framework will basically manage the scope and the lifespan of your objects. So maybe like dependency frameworks will usually give you the ability to specify the scope of an object. You can specify, for example, signed in scope or signed out scope. So maybe certain objects are created one time per login. Some objects are created one time per like state of the app. So it abstracts the state out of your code.
That you have to do yourself.
Well, something say like profile page is going to pop up all over your app rather than like do your allocation with all your dependency injection in like 72 places in your app, right? If you have some sort of dependency injection framework that does like auto wiring, right, and it knows how to do like construct it with all these additional dependencies, right? Because it's using some kind of, I don't know, service location or whatever, right? Instead of like changing, like you added another dependency to a class, right? Then you wouldn't have to like change it in all 72 places. You just change it the injection framework definition.
Yeah. Cool. So I'm going to pass it over to Uzair to talk a little bit about yeah.
All right, so I'm going to talk about how do I learn or help my team test. So the reason I want to talk about this is mainly because we actually had this problem when I joined Connected Lab. So a lot of people did not have this mentality of understanding the value of testing and how to like pick up testing within the projects that they're working on. So how do you do it? Testing is learned by doing. Okay, so you can talk about it all you want, but you will never learn it until you do. And having said, there are some methods that we use actually are connected to roll it out that we've tried to make people more comfortable with testing. But it's not something you can learn that you're not even. Like, most people, when they learn development in school, they're not thinking about testing as a main priority. It's the implementation and the design is usually the most important thing when you're taught in school or you're taught by whatever means. But testing, you can't get to that mentality until you're forcing yourself to think about it as a first priority. So how do we do it? We do things at Connected Lab. For example, we do ping pong pair programming. So at Connected, we actually one of our principles and our values is actually pair programming. So we pair program regularly on all our projects, and to increase our capabilities on learning how to test better, we actually do ping pong pairing. So what that means is that one person usually writes a test, the other person passes the test, and they go back and forth, back and forth, back and forth until they get like book size of the code done. And actually, it's very effective when we do that. We also have introduced the practice of coding katas. Coding katas, for those that don't know, is essentially like when you take a small problem that's kind of set that you can do in a small amount of time, but you iterate over it many times. So you could do it one time in one setting, and then you can do it again in another setting. But the goal of that is to get better at a certain technique by focusing on a certain area. So we've been actually doing this at Connected in two different ways. So one is like we actually pair up amongst the team, in amongst the entire engineering team, and we just take a problem and we have each pair go up and actually practice their testing skills or certain parts of their testing skills while solving a certain problem. We actually also, in addition to that, we do a group style, Randori style coding kata. So the Randori style coding kata is essentially when you have the entire team or a good bunch of people working together to solve a problem. So we have a pair at the front, and they're doing like a ping pong style. So one person writes a test, the other person passes the test, and then we swap in someone, and someone else comes out, and then everybody's watching while the pair is actually developing, and it's almost like a collaborative style of a kata. And the focus is essentially to try to improve the testing skills. And we've been doing this over the past about 5-6 months at Connected, and it's actually been very, very effective. Because we also try to tailor like the problems that we do to more real world scenarios than just like theoretical problems or very small problems. And in addition, we've kind of use those sessions to focus on certain areas that people just need a little bit more help with. Like, for example, dependency injection sounds like it can be very difficult for people who are not used to that concept or not used to like abstracting out dependencies. By nature, like we just don't think of that as we're learning. It's something that you have to just really pay attention to, and then you have to also focus on like things how you mock a certain thing, how you mock or stop certain areas of dependencies. That's something that's not as simple and straightforward as you would think it is, especially in very concrete examples. So we account for this type of training time, and we actually dedicate time to do that. And it's something that I would actually recommend people do as well, because it really gets you to focus on improvement for yourself as your team. We also, so as we dedicate time for improvement, so we do this during certain times during the week. We also share war stories and aha moments. So we always try to encourage people who have experience with testing and who have experience with like certain aha, this is how you do it, across a team. There's been cases where, for example, one developer is struggling for a couple of days, and then they just talk to someone who has a little more experience in testing, and they're like, oh, aha, that's how you do it, right? It's just a matter of like sharing that knowledge and sharing that experience, because not everybody has that experience in testing. So how do I get started in a legacy code base? Right? This is actually a very hard answer, because especially when something's been developed over time and there's no tests, how do you start? Right? It's very difficult. So what are some examples? As a team, what things you can do is quarantine or enforce standards, right? So look for areas that you can actually separate out and look to improve those separate areas, right? And enforce the standards in those areas. Or, for example, if you're touching something and you're actually improving it, use the Boy Scout principle, fix only what you touch. Or whenever you implement something, improve it. Write a test to try to help that one area. Other things you can do is prioritize components. So in any component that you're working on, if you feel is very important, that needs to be important, have a lot more testing added to it, prioritize that as a first area to focus on. Also, with regards to so have a single focus per season. So maybe you have a season of like right now you're working on a certain feature, or this is maybe our slow time or our time that we focus on this area of our code base. Have that as your focus for your testing, and then have regular retrospectives or pair swapping within your team. We do a lot of pair swapping, but have them regularly so you can spread around that knowledge. How to get better at testing and spread around some of the expertise around the team. So, a few objections.
Sure.
Go ahead. A few objections.
Okay. So a few objections. First one. So you're not crazy if you thought this, because like most of these objections are actually partially true. Some of them are also like there are reasons why they may not be true. But the first one is, it doesn't seem worthwhile spending time writing twice the code that delivers the same functionality, right? Like it just takes more time, especially if you're not experienced in testing. So I think what's not true about that is the idea that the time that you spend later on debugging, interpreting, and verifying code is less than the amount of time that you spend like test driving and running those tests, right? And I purposely kind of put in kind of big O notation to represent like as your code grows in size and as it kind of ages over time, this becomes like more and more, less and less true, this right here. Maybe for the first 2 weeks, this feels really true, but I think like it becomes less and less true, right? But what's true about that statement is that the ramp up time for testing is non-trivial. And I would say that like if you're really rushed about writing tests, writing bad tests, I think, is actually worse sometimes than writing no tests at all. Because what happens is like you write a bad test that's very like say implementation specific, very like it's not very input output. It's very hard to set up. There's a lot of like hard to read elements. When something breaks and someone else who hasn't seen it, they come by and they look at that test and it's failing. Not only are they afraid to make the code better, like I guess like it makes them extra afraid as opposed to safer, because now that test is failing and they know that test is there for a reason, but they can't understand what it's doing. So now it's actually frozen your poor architecture and your poor coding decisions into your code base. Right? So I would say like writing bad tests is sometimes worse than like not writing any tests at all. So I would say like it's true that it doesn't feel worthwhile, but in my mind, I would say like the time is maybe like around 2 months. Like once you hit about the 2 months time, you're going to start noticing the value of those tests no matter what. But give it time and make sure you like really devote time to write good tests. And what do I mean by good tests? Like basically things that follow the principles that we kind of outlined. Cool. The other objection that's very common, I think, is like testing is too heavyweight for an MVP. Let's wait till we think it's valuable. Right? Like you just got to get something out. This one's very tricky because I guess it is true that you have to demonstrate value really quickly for like small projects, but the misconception there is that only large code bases need tests. I think testing is more related to the age of the code base than it is to the size of the code base. And also thinking like that tends to like basically try to figure out like what is the return on investment for tests. And you can actually always justify not testing because once you don't test, it's harder to make changes and it's actually just faster to just follow kind of a sunk cost fallacy perspective and just go, well, okay, if we just like really, really check it this time, it's going to be faster than putting in like a test framework and doing it. So once you don't test, it's actually much harder to add it in because you've set that expectation and it's always going to feel like it's just quicker to just not test, right? Having said that, the value of tests is actually really hard to measure because what the value of test brings is it reduces something as opposed to like produce something visible, right? Like if all the disaster prevention mechanisms out there, like you never visibly see the value because the value is intrinsic to the fact that no disasters are happening. So it's very hard to measure, and not everything can be tested. So sometimes trying to achieve like really high code coverage is kind of like, it's not an end in itself. You do have to question what to test. So especially when you're like making an MVP and you're short on time, maybe you can't test everything. It's very important to figure out what components and stuff you're going to focus on, right? Like Uzair mentioned, like we're definitely testing our managers and services. Maybe we're not going to test so much some of our big controllers. So like definitely prioritize and think about what can and what should be tested. And then the last objection, my code can be just as good without tests. So we had this come up like right away at the beginning. So I would actually say it's not untrue, but I feel like saying that like my code can be just as good without tests is a little bit like saying I can be a great athlete without morning exercise routines. Have you heard of Jonathan Powers? Squash player. No. Look him up. Okay.
Have you heard of the fallacy of argument by analogies? How was your test case like
That's right. That's right. But I would say that it is a very good practice. Like it does when I first started doing like especially test driving feels really weird. Test driving means you write the test first before you actually write your implementations. You write a test, you get a failing test, and then you write the code that passes that test. You're just full of questions.
Do you have a requirement to build that test frame?
Like a very like strict rule. Like,
do you have a requirement that you are building the software for to build that test for?
Right. So like it starts with writing.
Or are you inversing the process of creating the requirement by writing the test and then writing the code that passes the test without having a requirement first?
Like have the requirement first.
You have the requirement first.
You have a requirement and then you write a test case against it, and then you write the code for it.
Yeah.
That passes the test case instead of related to the requirement indirectly.
Yeah, and the way that the requirement is written out can really inform how developers write tests. That's why it's really important to have very clear, like, given.
It also informs how you write the code.
it also informs how you. So it's an architecture decision almost upfront, right?
The criticism I'm trying to get at is you have to do it this way approach. This doesn't really make sense because all of the arguments for writing the test case first also applies to writing the code.
Right.
But anyways, I got more. Go.
I mean, those are good points. I think deciding how the code is going to work can be test driving will inform how that's going to look. So I've many times started to write a test and then realized that there's like a hidden dependency that I wasn't really thinking about, and then I had to go back and think about, hey, does that responsibility belong in this class? Or so like that kind of thinking will help you will reveal certain things about the code, is what I mean. So I definitely think like it's not like a dogmatic thing where you just do it that way, but I think doing it is a good discipline. Like it's a good type of practice, even if you don't always write it first. Like thinking about it is more important than writing it first. Cool. So with that, good luck. Smooth sailing on testing. Thank you. Yes.
Really sorry. Before we start asking questions,
Sure.
you had a slide up. I think it was the 5th slide.
Okay. Like one of these?
6. I can see it right there. Yes.
Yeah.
What are you trying to say here?
So this is part where I was trying to say that testing will usually challenge you a little bit on decisions. So for example, this way might result in more test contamination. So maybe you have an error. You have a reference in your test somewhere like earlier on in the test, and then you run a test, and that error gets populated, and then now the next test is going to be contaminated with that. Does that make sense? Where this is like a more input-output type of.
Sorry, I don't. You mean because you defined an error? You defined an error, and then you passed in a pointer to it.
Yeah.
And then now that, I mean, if I was testing, I would just mill that error out before the next call. No.
Right. So because in your test you have to write like an after each to nil it out, that indicates something about your code, right?
Yeah.
Right.
I guess my main point is I don't have a problem with that first one. I don't see a reason to change it.
So I don't have a problem with the first one either, but I was simply saying that with tests, sometimes situations will arise that will reveal that will say like one of these is producing a weird outcome, and it may be undesirable, it may be desirable, but because you're writing tests, it challenges you that way. You may want to keep it the same way, but it's up to you after thinking about it, right?
Okay.
Yeah.
In particular with this pattern that you're changing here, if you change to like handle data returns of value,
right?
Right. I mean, first of all, this thing is hard. This is a bad test because it introduces side effects because it returns void in its base implementation.
Right.
Right. And this error start with the auto releasing, right, is usually used for value like methods that return a value but also need to return a value by error, right? So by saying that you would change the first one to the second one,
right,
because it helps your tests, right? It's like there's a problem with your test, and now you're fixing the thing you're testing instead of fixing your test.
Right. So it's very important to not actually have tests inform your implementation. Like that's a part about like implementation agnosticness.
Yeah.
So like if
this is doing that.
This does do a little bit of that. So this is why like thinking about tests or doing like a test first kind of thinking forces you to think about how you're designing your code, right?
So because of a testing principle, you are now changing your interface, which then goes against the principles and patterns of the frameworks that are using, in particular system frameworks that handle this type of thing.
Exactly.
Go do this, return the data, and indirectly give you an error. So you are now going against the conventions of the platform that you're writing against in order to meet this external philosophy that then introduces a whole bunch of changes that you then need to either roll up and encapsulate and put behind all these other interfaces. Just because you're following this other pattern that is external to the platform that you're building for. Doesn't that create a lot of overhead? And then who tests those tests?
So when you say overhead, you're talking about like development effort time.
So what I'm trying to dig into here is this is a good example of you're now changing the API in order to make it testable based on a certain philosophy, which doesn't fall in line with the platform, like with the patterns of the framework. So now you're adding an additional layer of either indirection, obfuscation, complexity in order just to be able to run a test on it or follow these patterns of testing. Do you think that adds a whole bunch more cognitive load and makes this much more difficult in order to understand, rather than using the frameworks as they're provided?
So I wouldn't.
How do we balance that?
I wouldn't go and necessarily test the framework methods themselves, because those are like, that's really outside of the boundary of what you should be testing.
This is a perfect example of that all the frameworks are exactly like this.
Exactly.
So when I'm implementing, my patterns are going to be, I'm going to take, right? It's like, hey, there's some really smart people at Apple that have been doing this for a really long time. I'm going to mimic them rather than follow whatever the testing framework of the day is, which changes frequently. Right? So it's like, instead of following that pattern, I'm going to follow the tried and true pattern of the system. So this is where these two ideas. So how do you propose that we?
So I mean, like, if I were to give you like my unfiltered opinion, I would actually think this is not great. Like, I actually think this is better. So like, I would actually do it that way, and that's why I say like, I feel like well-architected code tend to also be testable because it's like very input-output. Like, it's easy to understand what goes in, and it's easy to figure out what's coming out. Right.
Sorry, this method is an input-output. It returns void.
Right. So this one doesn't. This one isn't an input-output one.
Yeah.
Right?
If this followed the standard C model, which is return value and then an optional error, which is essentially what it's trying to emulate, right? Then I fail to understand why you can't test the return value. In fact, for a test, do I care what the error is?
So I purposely left it void in this case because of the fact that like when there is a return type, this is like a very common pattern. But there are cases where it is you're doing something and then there is no return, but then you're still returning the error this way. And I would say, like, if that's the case, then like why would you do this? Why would you do this over this? Right?
To reduce cognitive overhead.
Yeah.
Right. You're at that point, you're then only dealing with one pattern throughout your app, right? And instead of like switching to one or the other based on the context in which you're in, right? It just reduces cognitive load of reading the test.
Right.
Also, Swift error handling, right? If you're taking the subjective C code and then using it in Swift, right, the bridging will automatically turn that first one into a throwing error for you, whereas the second one you no longer have that.
Right.
Yep. I have a totally different question.
Sure.
Can I just
You want to
clarify? Yeah, just to clarify, and then you go off.
When you're ready.
The bigger picture point that I was trying to get at was the conforming your tests, like writing your tests or writing your implementations to conform to a test pattern instead of patterns of the system. It's like that's where making that choice of like, oh, I have to write it this way because it's testable, as opposed to what the pattern should be. Is where I have a problem. Go off on your tangent because I talked about it.
So I'm not that familiar with the frameworks that you're using for the testing, so I'm curious how they approach the problem of localization in multiple languages.
So localization with multiple languages, you could. So there's actually no clear-cut way of testing for localization. just because, like, so the frameworks, I guess the answer is the frameworks themselves don't provide a specific way of testing localization. It depends on how you're doing localization. Like there's many ways you could do it from storyboard. You could put it in like the localization, like the strings. You could have like a key to string mapping, which is very popular. It also comes down to how you want to run your tests. So for a unit test suite, sometimes people don't care enough to run it in all languages. And sometimes people don't care enough to run it on all device sizes either, because they don't feel there's enough value there. So some people would argue that the best way to test is to actually put literals everywhere. You want to avoid as few so I guess what I'm trying to say is maybe you're trying to look for a string match, and maybe that string is your localization key or something like that. So some would argue that don't use the key, but make a literal there, because maybe the key changes and you get something totally different. Like you shouldn't have any sort of awareness of the implementation. You should think of your tests as a test example, like a sample output. So yeah, I guess like there's no clear answer there. If you want to test like multiple languages, I would basically suggest I would suggest using the keys in the assertions, or like loading up your strings and then like having like a kind of changing the locale when you're writing the test, and then maybe even having like locale as some sort of dependency that you can adjust.
And do these frameworks have support for testing accessibility features?
So yeah, so you can check the accessibility text if you want. It would be just like any other assertion. You just check like it's there type of thing.
So I'm not so much meaning the text. I mean, if a visually impaired person, for example, has their phone running accessibility mode, do these emulate it enough that we can be certain that the application is going to work properly for them?
I would say the answer is no.
Okay.
Testing UI is really hard.
Xcode UI testing.
Yeah.
We'll give you all of that. And it uses the accessibility.
UI testing.
It uses the accessibility data.
Yeah.
That's not really a unit test type of problem. I say.
Oh, I see.
Also, UI because UIKit behaves very like lazily when you're running like the test. Like if it doesn't have to draw, it won't draw. Like if you're testing a UI collection view, like the cells just won't show up until you have to manually tell it to like layout, right? So I find that typically testing, like for example, your frames are fitting correctly, like the overlaps, those things are very, very difficult. And I myself question the value of like going the extra mile to test that sometimes. So again, it comes down to how you want to test.
Thank you.
Yeah, you generally don't test frameworks if you don't know. Like if you're using a Pokemon or whatever, you expect it to develop.
Until it's burned you enough times that you
Stop. There's another talk. Stop.
I think.
Yeah, so just to illustrate any examples of projects that interface the user as well. So we can take a look. People with problem.
On the open source project that
I want to say like Alamo Fire or like those actually I don't know if Alamo Fire has.
are they using Quick and Nimble? I don't think
I'm not totally sure.
Alamo Fire might.
So if you go to Quick and Nimble, the GitHub page, they actually have a link to like projects that are using Quick and Nimble to test, and you can tap into it. I want to say like RX Swift, I feel like might be using it. I'm not totally sure. Yeah.
I have a simpler question probably. What about mocking the data? Because usually you have like some kind of protocol that you use to create objects.
Yeah.
I'm kind of new to this, and I sometimes have a hard time telling when I'm actually testing the thing that I'm trying to test, because sometimes I feel like I'm just creating like an isolated object, and I'm testing that, and like it won't actually change any unless I change the protocol itself. It won't actually like break or anything, and it's like it's pretty hard for me to tell how to like mock properly, and yeah, I guess just how to and when to do it.
So I think my perception about that is you have to think about input output. So sometimes you can write unit tests that are a little bit like integration tests too. You can actually supply like real objects or stuff like that. And it's testing like more than it should test. So you should always look at the class you're testing. Think about what is like the public interface of that class, including like the constructor, because the constructor will give you the method in which you can set up the preconditions for that test, right? And if usually that's where the mocking happens when you're supplying that. And then you have to figure out what you're asserting on afterwards. I find that like if you find that like your assertion are pretty meaningless, like they're basically like a tautology, it usually means that like maybe your code is either too modular or you're actually like exposing implementation for the sake of testing, which I would say is what it will result in is you'll end up rewriting tests whenever you change the implementation, which is like it's very brittle. Like you don't want to be doing that. So.
Quick two-part follow-on to that. First being in Swift, and I'm mostly just asking this to see if there's wisdom in the room about it, because these are two questions. When you at testable import, whatever framework it is that's a test, if you're needing to DI stuff into a class that would otherwise be strictly internal to the class, in other words, the only reason that you have like the interfacing protocol defined, the injection protocol defined, and the overload, the constructor with all of your dependency injection in it. You still need to declare all of that stuff public outside of that framework. Right? You still can't otherwise keep it inside the framework. So then the visibility of all of you have way more visibility into this internal framework than you would otherwise have. And I'm just wondering if anybody's got any good solutions to that. I mean, I guess what I'm saying is that DI, like it feels like the testing tools, like for want of a few small tweaks to the language or to the definition of it, that you could strictly have in a testing environment. Right. It wouldn't be things that you would need in a regular deployed environment. It feels like that could be, significantly mitigated. Right. It's a big problem for us. Our the surface of our our framework is way bigger than it would need if we weren't exposing that stuff that we need to be able to test it. You know what I mean?
Right, so I guess you're exposing something in your framework, and the constructor, because of constructor size is growing.
Well, no, because you have to be able to inject it somehow, right? To be able to inject a mock version of it, you have to know what that protocol is that you're mocking. Right. Right, and otherwise that would be internal to the framework. You wouldn't need to expose it.
So what you're saying is you're having too many dependencies, you think?
The dependencies are necessarily public. They have to be, because your mocks live in your testing framework, not in the framework that you're testing.
So, they need to be internal.
Sorry?
Internal.
Yeah, they would otherwise be internal.
At testable import can test internal methods as well as public ones.
Yeah. It's what? So you have an
but then the issue becomes that you have these default parameters that you would otherwise be providing to the constructor function that are that end up getting confused with a less variable constructor definition. So you need to be able to expose those dependencies to the consumer framework, at which point you're no longer able to mark them as internal. They have become by definition public.
And because it's a protocol that you're that defines the thing you're overloading.
Are you testing an app or are you testing a framework?
So you have
I would mark the methods that have your injected dependencies as be internal, because your test harness can see those, and then for the ones that are visible to your basically your framework consumer, only have the what's absolutely necessary.
I'll bring it on the channel.
Yeah.
Any other questions?
Yeah. Any thoughts on tests that need to run on device? For example, if you want to do some performance tests, say on lowest spec device that you support, or for example, something with regards to, like, say, push notifications that work in the simulator as far as like 11. So any thoughts on that, or just entirely through like something like Travis?
I would defer that to like UI testing or a different test target, because the moment it's on device, like the tests run less deterministically. And one of the things I think a unit test suite should be good at is running very reliably, very quickly. So yeah, I would add like maybe a separate test target, add that on there, and then that may or may not be something that you run like all the time, but it's something that you will periodically run where you have it scheduled differently. Yeah, I don't know if that answers your question.
The BDD doesn't really test performance, just testing logic. So if you test performance here, you need to have a separate test unit. Probably it won't be like BDD framework based.
Yes.
Are you going to drinks after?
I don't think I can, but I'll stick around for a bit.
Right. Yeah. I was going to say, I think we owe you.